Hello and welcome back to my channel. In this video, we are going to learn different types of examples from Surds topic. Now let us look at the first question. Express 5 over 2 minus radical 3 in the form a plus b radical 3, where a and b are integers. So they want us to write 5 over 2 minus radical 3 or square root of 3 in this form. To do this, what we are supposed to do is, we have to use the rationalization step. Rationalization is a step where we take the denominator or the term which is having a square root or any radical term, and we write its conjugate. Conjugate in the sense, if we have a negative here, we are going to write a opposite sign. So 2 plus radical 3 over 2 plus radical 3. So we have to multiply and divide the conjugate of 2 minus radical 3 over here. This is called as rationalization. The next step is we have to combine the numerators. So we have to multiply 5 with 2 plus radical 3. And we are going to multiply the denominators. 2 minus radical 3 and 2 plus radical 3. After this, we have to just distribute the bracket. So 5 times 2 is 10 plus, since there is a plus here, 5 times radical 3 is 5 radical 3 divided by, this you can see it's a pair which is same but having the opposite signs. So we can write it as 2 squared plus with a minus gives us minus, and radical 3 times radical 3 is radical 3 squared. I have used the algebraic identity over here, which is a minus b times a plus b gives us a squared minus b squared. So if you remember this, it will be very easy to solve the Surds. So the denominator is solved using this identity. Then the numerator, we just write it as 10 plus 5 radical 3, and in the denominator 2 squared is 4 minus radical 3 squared is 3. Remember, if we are squaring a radical or a square root, the square root disappears. So it becomes 10 plus 5 radical 3 over 4 minus 3 is 1. So we simply write it as 10 plus 5 radical 3. This is how we solve this kind of Surd. Now if you see, they had wanted us to write the answer in the format a plus b radical 3. So we can compare these both things and we can say that a is equal to 10 and b is equal to 5. This is how we get by comparison. So this is our answer, where we have got the value of a and value of b. This is a second type of example from the Surds. Express square root 45 or radical 45 plus 20 over square root of 5 in the form k root 5. That means whatever answer we get at the end should be having the form of k root 5. Now, square root of 45. By chance, if they have asked you not to calculate using the calculator, here is a way to solve the radicals. We usually split the radicals as a combination of a square number multiplied with another non-square number. So 45, we can see that it is nothing but it's a multiplication of 9, which is a square number, times 5, which is a non-square number. So this is the way and the easiest way to solve the radicals. So always think of splitting the bigger radicals or bigger numbers as a combination of a square number and a non-square number. Now this could be split as square root of 9 times square root of 5. Square root of 9 is 3 and square root of 5 cannot be simplified, so we just write it as square root of 5. So this is the simplest form of square root of 45. Now let us look at 20 over radical 5. How can we solve it? Now if we have a square root number in the denominator, we go for again rationalization. Here we are going to multiply and divide with the radical given over here. So remember to multiply as well as divide the same number. Here 20 gets multiplied with radical 5. So we write it as 20 radical 5. And radical 5 times radical 5, it is radical 5 squared. So here we write it as 20 radical 5. And remember, if we square a square root number, the square root disappears and we are left with only 5. Now further simplifying this, we get 5 one times and 5 4 times. So we finally have 4 radical 5 as the simplest answer for 20 over radical 5. Now we have to combine the answer of square root of 45 and 20 over root 5. So let us check if we get the answer in this form or not. Square root of 45, we had got it as 3 root 5 plus we have got the answer of 20 over radical 5 as 4 root 5. Here we have to add the numbers keeping the radical 5 same. So we get 3 plus 4 is 7 square root 5. Now this is of the form k root 5 where k is equal to 7 by comparison. So k position is taken by the 7. So k is equal to 7. This is the way we solve this example. Now let us look at the third type of example. Express square root 300 minus square root of 48 in the form k root 3. So whatever answer we get should be in the form of k root 3, where k is an integer. So k can take the value as -1 or +2 or 0, anything it could be. So, but it has to be an integer. So let's start with the first one. Square root of 300 minus square root of 48. This is for 3 marks. So as much as possible, avoid using the calculators because they really want to see the steps, how you are solving it. Now let me start with the first one. Square root of 300. As I had said, always try to resolve this given number as one of the square number multiplied with a non-square number. Here I can see that 300 can be resolved or split as 3 times 100. Where 3 is a non-square number and 100 is a square number. Now I can simply split it as square root of 3 times square root of 100. Now square root of 100 is 10 and square root of 3 cannot be simplified. So this is the most simplified answer for square root of 300. Now let us look at square root of 48. Now square root of 48 can be split as 16 times 3. So we can again see that 16 is a square number and 3 is a non-square number. So I can again split this further as square root of 16 times square root of 3. And square root of 16 we know that it is 4 and square root of 3 cannot be simplified. So we write it the same way. So 4 radical 3 or 4 square root 3 is the simplest answer for square root 48. Now we have to just combine these two values which we have got. So square root of 300 minus square root of 48 could be written as 10 root 3 minus 4 root 3, which we get as 6 root 3, because 10 minus 4 is 6 and square root of 3 and square root of 3 is a common term. To write it more specifically, we can take square root of 3 common and write it as 10 minus 4. So 10 minus 4 is 6 and square root of 3 stays. Now this is of the form k root 3 and we got the value of k by comparison as 6. This is how we solve this example. Now let us look at the second question. Express 15 plus square root of 40 over square root of 5 in the form a root 5 plus b root 2. So let me just copy down the question here. So 15 plus square root of 40 over square root of 5 should be written in the form a root 5 plus b root 2. Okay, so let us start solving this example. Now as you can see, there is a square root term or a radical term in the denominator. So as soon as you see this, you have to think about rationalization. So take the denominator, multiply it and divide it. This is called as rationalization. Now once you do this, what we are going to do is, we are going to combine the numerators and write it as 15 plus square root of 40 multiplied with square root of 5, and in the denominator we get square root of 5 the whole square. Square root of 5 times square root of 5. So here we are going to distribute the brackets, and square root of 5 times 15 gives us 15 root 5 and root 5 times root 40 gives us root 5 and root 40 multiplies this way. So both are having square roots, so you can multiply them here. But here 15 was not under the square root, so we cannot multiply 15 and 5 inside the square root. So be careful with this step. Over square root of 5 the whole square. As we are squaring the square root disappears and only 5 stays. Now here we write it as 15 root 5 plus square root of 5 times 40 is 200 over 5. Now look at the square root of 200. Root 5 cannot be simplified because it's in the most simplest form. But square root of 200 can be split as a non-square number, which is 2, and a square number 100. So we can split this as square root of 2 times square root of 100, which gives us square root of 2 times square root of 100 is 10. So it is 10 root 2. So in place of root 200, I am going to write 10 radical 2. So here we write 15 root 5 plus 10 root 2 over 5. I can further factorize the numerator where I can see 15 and 10 go in the table of 5. So I can take out 5 common out, and here we can just write it as 3 radical 5 plus 2 radical 2. So I have factorized the numerator divided by 5. Now I can simply cancel this 5 and this 5, and my final answer is going to be 3 root 5 plus 2 root 2. So let us check whether we have got the answer in the form they have asked. Okay, they had asked us to get in the form a root 5 plus b root 2. So we have got it as a root 5 plus b root 2. So by comparison we can say a is equal to 3 and b is equal to 2. So we have solved the example. Now let us look at the last example. Express 15 plus root 3 over 3 minus root 3 in the form a plus b root 3, where a and b are integers. So we have to get the answer for this one in the form a plus b root 3. Now let us start solving it. 15 minus square root of 3 over 3 minus square root of 3. We have to again use the rationalization over here. As you can see, there is a square root in the denominator. And since there are two terms, we are going to use its conjugate. So 3 minus root 3 becomes 3 plus root 3 over 3 plus root 3. So if it is minus here, we use plus. And if here we have a plus, we use a minus here. Now after rationalizing it, we are going to multiply the numerators and multiply the denominators. So let me write it together. 15 minus square root of 3 times 3 plus square root of 3 divided by 3 minus square root of 3 and 3 plus square root of 3. Here we have to use the distribution, the FOIL. We have to open up the brackets. So 15 times 3, that is going to be 45. And 15 times plus root 3 gives us plus 15 root 3. And then we have minus root 3 times 3, that gives us minus 3 root 3. And we have minus root 3 times minus plus root 3. So it becomes minus root 3 squared divided by, since we have the same term but with opposite sign, we can write it as 3 squared minus square root of 3 whole square. You have to use the algebraic identity I have shown in the previous example for this denominator. So here we get 45. Now if you see these two terms, they are like terms because they have the same radicals. So 15 minus 3 gives you plus 12. Radical 3 remains there. Minus, as we know, if we are squaring the square root, the square root disappears. So it becomes 3. Over 3 square is 9 and square root square is So here we get it as 45 and minus 3 are like terms again. So we can write it as 45 minus 3 is 42 plus 12 root 3 over 6. Now if you look at the denominator 6, we can see that 42 and 12 also go in the table of 6. So we have to take out 6 common here. 6. We are factorizing the numerator. 6 7 times is 42 plus 6 2 times is 12 square root of 3 over 6. So we are going to divide 6 with 6 and we are left with 7 plus 2 equal to 3. So let us see if we have got the answer in the asked format or not. A plus B root 3. Yes, we have got it as A plus B root 3. Again comparing, A is equal to 7 and B is equal to 2. We have got the answer. This is the way we will solve the examples from the Surds chapter. Thanks for watching.